Today, we're going to add normals to our procedural bricks in Unreal and Unity. Let's go. Alright, so in last week's video, we added color to our procedurally generated brick pattern. And 2 weeks ago, we learned how to create this brick pattern. And today, our focus is going to be on generating normals for our bricks. Right now, our brick pattern is just kind of flat, and we want to give our bricks some shape. And what we have here with our brick pattern is kind of like a bump map. We have areas where the bricks are high that are white, and where they're low that are black. But one problem that we have with this rectangle node, the way that it's generating the bricks right now, is that our pattern is very sharp. We have really hard areas where the bricks are black and really soft areas where the bricks are white. And so what we're going to be doing today is replacing this rectangle node with a version that generates an SDF, or assigned distance field. And what that's going to give us is a soft gradient in our bricks. The pixel that's right in the middle of the brick is going to be white, and then as we move toward the darker mortar areas of the bricks, the pixel's going to change from white to black. So it's going to give us gradients, and then we'll be able to use those gradients to shape our bricks and create normals. So that's the process that we're going to follow today. We're going to start out doing this in Unity, and then we'll switch over to Unreal, and I'll show you how to do the same thing in that engine as well. All right, so in order to create a version of the rectangle node that generates an SDF, first we need to create a subgraph. And I've already created this subgraph right here. It's called Rectangle SDF, and I'm going to walk you through the process of creating this subgraph. The first thing that we need is UV coordinates. So we have our UV coordinates here, or we have this input node. So if I open the blackboard here, you can see I have this UV node for input. And then I'm using this branch on input connection node, so that if the UV node is empty in my subgraph, if nothing is connected to it, it's going to use the default UVs instead. And I do want to go over briefly, I've done this before on the channel, but I do want to go over briefly how I set up this branch on input connection node. If I open my graph inspector here and select my UVs, you can see that I've checked use custom binding, and then I've given it a label of UV. And what that does is it sets it up so that my branch on input connection node can switch between using whatever is connected to this input port and the default here. So I set my input UVs to the input and connected, and when the port is not connected, I give it a default set of UV coordinates here. All right, so what that does is it gives us our UV coordinates like this, but we want to create a rectangle with the center in the middle here. And so in order to do that, we change our UV coordinates from a range of 0 to 1 on the X and Y axes. And so what we're going to do is change it to a range of -1 to 1. And so we multiply by 2 and subtract 1. And that's going to give us an image that looks like this, which is basically we're going from -1 to 1 on both axes. So we've got our 0 pivot point right there in the center. So multiply by 2, subtract 1 to put our pivot point in the center. And then we're going to use our absolute node to make it so that all areas of this are the same. So from the center outward, we're going from 0 to 1, 0 to 1, 0 to 1, 0 to 1 in all directions. Our absolute node is taking the areas that used to be negative over here on this side and turning them positive. So all 4 of our quadrants are basically mirrored images of each other. All right. Then we're going to add our width and our height, and that's basically the dimensions of our bricks. And if we take a look at our UV coordinates here, it's basically making it's shrinking in the UV coordinate range, so we're going from 0 to 1 earlier. And then we split, and we're taking the X component and the Y component and finding whichever of those is larger. Now you can see, I'll zoom in here, and you can see that we're starting to get this gradient here where it's white out here in this region, and then as we come in toward the center, it's darker here in the middle. And that is the beginning of our sign distance field. But we actually want the opposite of this. We want it to be black out here and then white in here in the middle. So to get the opposite, all we need to do is use a 1- node, and that flips it around. So now we have a sign distance field. We have white here in the middle and then black out here on the edges. But this gradient doesn't quite go all the way to 1. And so in order to get that to happen, we're just going to multiply it by 2. And that gives us our final result, which we can then saturate and then pass out. So if we take a look at the whole thing together one more time, we start out with our UV coordinates, multiply by 2 and subtract 1 to center them. Then use our absolute node to flip our negatives positive, so we get 4 quadrants that are the same. Then we add our width and height, split, find whichever axis is greater, and then flip it around 1-, multiply by 2, saturate, and that's it. And this is going to give us a signed distance field of a rectangle. All right, so let's switch back to our procedural brick pattern, and we'll come down here and find our rectangle SDF subgraph and drag it in. And we want to set our preview here to preview 2D so that we can actually see our shape. So we're going to replace this rectangle node with our rectangle SDF node. So I'm going to wire my UVs in here, and that's going to give us this rectangle shape here. And we need to adjust our input values just a little bit. So I'm going to type in for our width and height input values here, 0.07 and 0.14. And that is going to give us some nice soft gradients here. Can you see how on this version we're getting hard edges, but on this version we're getting some nice soft fall off. And this is what we can use to generate our normals. So the next thing that we need to do is generate a couple of different patterns from our SDF. We need to control this fall off gradient here. And the way that we do that is with an inverse lerp node. So I'm going to add an inverse lerp. And the first inverse lerp that we need is a rectangle pattern kind of like this with hard edges that we can use to blend our colors with. And so let's just move this rectangle pattern out of the way. We'll take our rectangle SDF here and plug it into our inverse lerp. And if we want to get hard edges from an SDF, these minimum and maximum values need to be fairly close together. So I'm going to use a value of 0 there for my minimum, and then 0.01 for my maximum. And that's just going to give me this image with hard black and white edges, which I can then use to generate my colors. So we'll connect that up, and when it finishes compiling, now you can see that, oh, I've completely ruined it. And so the reason that I'm not getting the colors working correctly is because I forgot to add a saturate node. Anytime you use an inverse lerp, generally want to saturate the result, and then we'll plug that in, and we'll go back to getting our colors the way that we had them before. All right, now we need to create the version of our gradient here that we're going to use for our normals. So I'm going to add another inverse lerp and saturate. I'll just copy and paste these two down here. And for this one, I want a little bit smoother gradient. So I'm going to increase the distance between my minimum and my maximum values. For this one, I'm going to use a value of 0.3. And now you can see that my edges are a little bit softer here. And what I've done is I've basically created a bump map. And now Unity has a node that I can use to convert my bump map into a normal. It's called normal from height. So I'm going to add the normal from height node. And what this does is it takes a height value in and it converts it to a normal map. All right, very cool. So now the last thing that I need to do is just plug my normal map into my normal input slot here. And there you go. Now my bump map, or now my brick pattern, has a nice normal map. And if we change our preview over here to a cube, now we can rotate around and you can see that I've got normals and my bricks look like they have depth to them. Now, one thing that you might notice is that my edges here are kind of hard. And the reason for that is that this normal from height node that we're using generates a pattern that's kind of low quality. It's using derivative math to generate our normals. And there's no anti-aliasing in that. So you can see that, especially when I look at it edge on here, there's quite a bit of jagginess. So that's one downside and limitation to this method. But we are able to generate normals from our brick pattern by, instead of using our standard rectangle subgraph or node, by using the rectangle's sign distance field instead. And that gives us a lot of control over our rectangle masks. We're able to create one that's specifically for the color, and we're able to create one here that's specifically for our normals. All right, so that's what I'm going to show you today in Unity. Next week, I'm going to show you how to create a little bit of variation in our pattern. If we take a look here at our brick pattern, you can see that everything is like perfectly aligned and very clean looking. And if we want to add a little bit more like organicness and irregularity to our pattern, I'm going to show you how to break it up and make it more interesting. So that'll be next week. But for now, let's switch over to Unreal and I'll show you how to generate our normal map for the bricks in that engine as well. All right, so here we are in Unreal, and I've created the same normal map here in Unreal that I did in Unity. Let's go over what I did. So just like I did in Unity, I replaced the rectangle generating node with one called rectangle SDF. And what this is doing is, instead of creating a hard black and white pattern, it's creating a pattern with a nice gradient. So let's take a look at what this one looks like. It's not quite as clear in Unreal, but you can see here that there's a gradient from white in the middle of the bricks to black at the edges. All right, so let's just briefly take a look at what it looks like inside our rectangle SDF material function. So we're generating this rectangle shape with our sign distance field. We start out with our texture coordinates, and those become the default input for our input UV node here. You can see we've set this to UV, we've set it to vector 2, and we've checked the use preview value as default. We also have an input for width and height, and you can see that's set to vector 2 here. And we've given it a default of 0.5 and 0.5. which is why we see a rectangle shape that's half the space here. Okay, so we have our input UVs. We multiply by 2 and subtract 1 so that we can center our pivot point of the UVs right in the center. And then we get the absolute value, which means we have 4 quadrants of mirror kind of radiating out from the center. And then to that, we add our input width and height. Then we take our 2 dimensions, our width and our height, and we figure out whichever one of those is greater with the max node. And if we take a look at this max node here, you can see that you can just like barely make out this SDF pattern. and it gets darker in the middle. And what we actually want is the opposite of that. And so we're going to do the 1 minus, which gives us this. Then we multiply by 2 and saturate, which gives us our final result of a sign distance field for our rectangle. Cool, so now we can jump back out and see how we're going to use this to create the rest of the pattern. And once we have this signed distance field pattern, or SDF, we can use it to generate multiple variations of the bricks. And so I've used this inverse lerp node here to generate one variation. This is the sharp version that we need for the colors. So if I right click here and pick Start Previewing Node again, here on this one you can see that I've got sharp edges between my white bricks and my black mortar. And then I'm able to use that to define my color. But if we come down here to the version that I'm using for my bump map, you can see that I've put in different values. So for this inverse lerp, I've got 0 and 0.01 and then saturated. And for this version, I've got 0 and 0.3. Now let me show you the reason for that. If I pick Start Preview here, you can see that I've got more of a gradient on these, and that's what I need to use as a bump map. So the next thing that I need to do is convert this height, where I've got my low values here and my high values here in the middle of the brick. I need to convert this height to normals instead. Now in Unity I was able to use the node called normal from height, but in Unreal it's a little bit different. I'm going to create my normals using the combination of these two nodes. This one's called Prepare Perturb Normal HQ, and this one's called Perturb Normal HQ. So this one apparently sets up our data, and then this one actually does the conversion. And so what this is doing is it takes our height map and it converts it into normal data. So you can see that these nodes are sort of meant for each other. This one creates our output values, and then this one takes those values in and it spits out a world space normal. Now, one thing that's really important to notice here is that this normal coming out of Perturb Normal HQ is in world space. And so you have two options with this normal output. I've used the first one just because it's simpler, but you'll probably want to use the second one because it's less expensive in terms of performance. What I've done is just use the transform vector node to take my world space normal to tangent space and then plugged it in. But I think there's a way, if we select our root node over here, I think there's a way in the settings where we can actually take it or tell it to use an input that's a world space normal instead of a tangent space normal. Let's take a look really quick. Yeah, there it is. So we have this entry called tangent space normal, and it's checked. And if I mouse over it, you can see the tooltip there says that it determines whether to use a tangent space normal or a world space normal. So if I didn't want to use this transform vector, I could save a little performance by unchecking the tangent space normal here and then using a world space normal instead. All right, so we used our rectangle SDF to create a bump map with our inverse lerp here. And then we converted our bump map to a normal map in world space. And then we told our root node here to accept a world space normal. And now if we take a look at our results, you can see that our bricks have some really nice depth and dimension to them. Instead of just being a flat surface, we've got some nicely shaped bricks. All right, like I said a minute ago, next week we're going to talk about how to warp these bricks up just a little bit. Right now the pattern is perfect and clean, and what we want to do is add some variety and kind of give the bricks a little bit more interesting shape. So that's what we'll be covering next week. I hope you enjoyed today's video and that you learned a little bit about transforming height maps or sign distance fields into normal maps procedurally. And I hope you're enjoying this series as we go along, learning how to create our procedural bricks. All right, have a great week, everybody.